Okay, so we are going to take some notes on direct variation. So direct variation is, we will write two quantities, x and y, show direct variation when y equals kx and k does not equal 0. K is the constant of variation. Y is said to vary directly with x. Okay, so there are different things that must, different requirements of direct variation. So whenever we talk about direct variation in a graph, that means that the line has to go through the origin. So one, it's a positive slope through the origin. So if you have a graph, I'm just going to do like a 3 by 3 like this. Then your line is going to go through the origin. It doesn't have to go through this, like it doesn't have to cut this in half or anything. It could be any slope that goes through the origin and is positive. Okay, the second thing is the equation of the line is y equals kx. So we have, for a graph, we have the equation. So then third would be table of values. I don't like tables. It should just say table of values. Or points, or like an XY point. So I'm going to put table or points on the line, or if they just give you the points. You can find the k value by dividing y over x. You don't have to do change of y over change of x. It's just y over x to find your constant of variation. Okay, so those are the 3 requirements. So let's look at the slides that we're supposed to do. Let me see. Slides 13 and 14. So we'll be able to do this on paper and then just put your a picture of your work on there, or you can fill it in as we go if your internet's working. Okay, so direct variation.
Will it like share to us on Google Drive?
Okay, on slide 13, direct variation is a specific relationship in which there is a constant. What? We just learned this. Of what? Variation, yeah. You just need to write it down because your internet's not working. That's fine. Between all ordered pairs. So there's a constant of variation between all ordered pairs. Direct variation equations are written in the form. What is our equation that we use? Yep. Y equals kx. Finding the constant k. So if it is a direct variation relationship, then whenever you do your constant of variation, your constant should be the same every time. You shouldn't have a different constant of variation for individual points. Like on this one, we have points 1, 4, 2, 8, 3, 12, 4, 16. So we're looking for the constant of variation and then write the equation represented by the relationship. So remember how we wrote from a table or points, our constant is found by doing y over x. So on that first one, we had what? 1, 4, what was it? 2, 8, 3, 12, and 4, 16. So to find our constant of variation, we would do k equals y over x. So this is our x, this is our y. And if it is a direct variation relationship, then you should have the same k value every time. So y over x. So this would be 4 over 1. 2 over 8. I mean, we do 8 over 2 because it's y over x. What does 8 over 2 equal? What does 4 over 1 equal? 4. Okay. Then the next one is y over x. So it'd be 12 over 3, which also equals 4. 4, 16, y over x. 16 over 4 equals 4. So our constant of variation, k equals 4. And then we write our equation now. Our equation is written as y equals kx. So just y equals 4x. So that's what we can write here. K equals 4, y equals 4x. 4 times whatever x is. So if you look here, it says 1, 4. If I multiply the x value times 4, I should get the y value. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. Okay, let's do the next one. Maybe we can do it just by looking at it now. -6, 3, -4, 2, 0, 0, 2, -1. What do y'all think it is? -1/2? So I believe I made a mistake on our notes then, because we can have positive, we can have negative or negative slope through the origin. So I'm going to draw a little line, negative slope through the origin. Hey, y'all ready? Okay. So if we look at this one, y'all already said -1/2, right? And so we could find that by doing y over x. So on my paper, that's what I'm going to do. I'm not going to write the points. I'm just going to do y over x. So 3 over -6. Which equals -1/2. And you could put the negative on top or bottom or out front. I like to just put it out front. So then the next one would be 2 over -4. Which again equals -1/2. And so on, right? So we have k equals -1/2. So then the equation is y equals -1/2x. So k equals -1/2. Y equals -1/2 x. Okay, so the table of values is the same thing. You're just doing y divided by x to find your constant of variation. So on number 3, we have -12 and -8. I'm going to go to another page of my composition book. So we're doing y over x. So that would be -8 over -12. -6 over 4. 0 over 0. And 2 over 3. So if we were to reduce all of these ratios of y over x, we should get the same value. 1/2, but, well, no. Would it be 2/3? Yeah, it'd be 2/3. Because if you reduce this, you have the denominator that's greater. So k equals 2/3. Then our equation is y equals 2/3 x. Okay, the next one, number 4. Let's do y over x to find our constant of variation and then write our equation. So I'll give you a second to do that. well, more than a second. I'll pause it for a sec. Okay, let's go ahead and look at it. Here's what I wrote down, just the y over x. So whenever you reduce them, what do you get k equals? -3, and then what's the equation? Yep, good. So the -3 is your slope, and it's also your constant of variation. Okay, let's look at the next part of this same slide. Finding missing values. So if the following order pairs represent a direct variation, find the missing value. So we have if x equals -18 when, y equals -18 when x equals 3, find x when y equals 30. You're like, what? What is this talking about? All right, so let's write down our information. So 5, we have y equals -18 when x equals 3. So using just that information, let's find our constant of variation. So we'll just look at the y equals -18 when x equals 3. Yep, because it'd be -18 over 3. So k equals -18 over 3, which gives us -6. So we know that our constant has to equal -6. And so let's see, what else does it give us? Find x when y equals 30. So k equals y over x, right? So that'd be 30 over what gives us the -6? Yeah, so we know it has to equal -5. This is our x. So x equals -5. So let's write what k is, and then we'll write what x is. And I'm going ahead and writing x equals -5 and y equals 30. So I'm going to pause it right now, and I'm going to let you do 6, 7, and 8 as I walk around the room. So this one is a little bit harder, so I'm going to give you a hint on here. We have this information, y equals 80 when x equals 32. So we'll do y over x, 80 over 32, which I reduced by hand because that's just kind of what I was thinking at the time. So I got 5 over 2, which would equal 2.5, right? But I want to make it as simple as possible. So I'm going to just leave it as my fraction 5 over 2. Because normally when we have our slope, when we graph, we normally have it as a fraction anyway. So let's leave it as a fraction. So now when find x when y equals 100. So we have y over x equals, this is supposed to equal that same constant of variation. So we can write it as 5 over 2. I first did 2.5, but that just didn't make sense to me. But if I look at just this, not the k, not anything else, just look at it just like this. Think about your earlier years in math. What do you do to solve an unknown whenever you have two fractions? Cross multiply and divide, yes. So that's what you'll do here. cross multiply and divide. So if I multiply, I get 5x equals 200. Divide by 5. I get x equals what? 40. So just to double check, do 100 divided by 40 and see if that equals 5/2 or really 2.5, right? Because I want to look at it both ways. So if I do 100 divided by 40, I get 2.5. So that's what I wanted. So x equals 40. So go ahead and fill that in on your digital interactive notebook. So k equals 5/2, which equals 2.5. So I'm writing it in both forms, fraction form and decimal form. And then x equals 40 when y equals 100. Okay, so now I want you to do 7 and 8. You should be able to do those knowing what we did to solve 6. So I'm going to pause. Okay, so let me go ahead and show you mine. So here's number 7. So something that you got to make sure that you pay attention to, it says find y when x equals 12. So after you find your k value, your unknown is y. So it's y over 12 equals -5/2, and you solve it that way. So we know the k is -5/2 or -2.5. And then the next one, -7/-28 gives you a +1/4. Then you're finding y again, so that's your unknown on top. Set up your proportion, and then you solve to get y equals 5. So fill out your information on your digital interactive notebook, and we're done for today.